In the previous video, we looked at managing ESXi based storage. In this video, we are going to look at LUN masking, both from the storage array side and from the ESXi side. So in this video, we will take a look at LUN masking, what and why. LUN is the logical unit number. It's a throwback from the old days of SCSI, where it basically was a logical unit or a logical disk that was created on a larger device. The LUN masking is really necessary for security reasons, as well as probably just for sanity in a production environment, because you don't want all servers to be accessing all LUNs or all logical disks. So we will look at configuring LUN masking on a ESXi storage array that I have in place. LUN masking is done in a very similar manner in other kinds of storage arrays as well. We will also look to see how LUN masking can be configured on ESXi. It comes in handy because you don't want your ESXi clusters or individual hosts. Usually it's good practice to let all hosts in a given cluster access all the LUNs. So usually this would be a matter of hosts in different clusters, basically making sure that those hosts see only the storage that they require. Now masking, LUN masking comes hand in hand with something called zoning, storage zoning. It's almost like VLANs within a storage network, where you make sure that certain HBAs and certain end storage devices are the only ones that can talk to one another, and anything not in that pool of devices, which is basically the zone, cannot actually communicate. So with that, let's move to talking a little bit about LUN masking, what and why, and then we will look at the storage array and then the ESXi. So I'm in the storage manager for my Synology array. It's reasonably easy to explain what LUN masking is and why one would use it. If you look at this masking section with an initiator IQN, what we are saying here is that any initiator, in this case it's an ESXi initiator, in the case of fiber channel for example it would be a worldwide name, any initiator would have access, read-write access to this target and the LUNs behind that target, except for this one specific host, which is ESXi04. So in this case what I've done is I've basically I'm saying that ESXi04 does not need access to the LUNs behind this target because of various reasons. For example, ESXi04 may be an extremely old host. It may be at a software level, for example, in its operating system, that does not support this storage array very well and could cause problems. And especially in a shared storage environment, in a virtualized data center, that happens quite a bit, where hosts share devices and then you don't want one host to cause problems to all the others simply because it's not up to date. So that would be one reason. Another reason could be because of security. You may have a set of hosts which access storage that contains extremely business critical data. You want to be sure that no one can access that except a certain number of hosts, and so you use LUN masking for that. You would also use that zoning, as we discussed before, is basically defining a set of initiators and targets that can talk to one another. So obviously that would be very useful in that security situation as well. You could also have a situation where certain devices are brand new, and usually that means they are very fast storage devices. You could have, again, older hosts with lower levels of software that cannot make use of that high-speed capability. So you want to mask off those LUNs from those hosts. You could also zone them out as well. So there are many ways in which you can basically eliminate host being able to access a LUN, and that's what LUN masking basically does. So to very quickly look at how one can do the LUN masking, we edit this, we go into the masking tab, and this is just the user interface for this Synology. most other storage arrays also do it quite simply. I can create another rule where I would then pick up an IQN. The IQN would be picked up from the initiator side. So if I go to an ESXi host, I can pick up the initiator name from there, and then I can specify what kind of access. So for example, in this case, I've said we can edit this one, and I can say that instead of giving it no access, I give it read-only access, or I can give it read-write access, in which case it becomes the same as the default privileges. A good security measure is actually this, where you look at the default privileges, and then instead of making the permission read-write, you make it no access, and then specific hosts are then given read-write access to that. So the default, I change the default from read-write access to no access, and now I can very securely say, okay, only these hosts can actually do read-write to this target, and that is usually a much better way to do this. Of course, I have already ESXi host talking to this, so I will cancel out of this, or better, I will actually explicitly specify what I'm looking for, and then I hit OK, and that takes care. Of course, it's going to, I'll have to do a rescan again, it looks like, before. There we go. It took a few minutes for those TCP connections to be connected again. So if you recall, these are the VM kernel addresses through 4 VM kernel adapters talking to 2 NICs on the storage array. So that was interesting in its own right. We should now take a look at how one can implement LUN masking on ESXi, and that is done from the command line. So we are back at 192.168.0.201, and we're going to investigate something called claim rules. So ESXi storage core claim rule list, and this will list what are called claim rules. So let's investigate this a little bit. So you look at the names. Okay, so these are the plugins basically, and this is of type transport. So what it basically says here is, and it's really a little bit difficult to understand here, but this claim rule with a rule ID of 0 is part of the native multi-pathing plugin, and is applicable for transports that are basically USB transports. Now the ones that are interesting in terms of LUN masking are the ones that are basically mask paths. So when you have a plugin with the very special name of mask_path, all in caps, we can then specify filters essentially, which can be by vendor and can be by vendor and a certain model. Okay, so that when the ESXi host and the PSA with the NMP goes in there and looks at all the various storage that are available, it checks to see if there is a storage that has a vendor called Dell and a model called Universal Export, and if that's the case, the paths that it sees to that device are masked out. Now there are various ways in which one can actually filter, and one very common one is called location. And when you say a location, it basically is the actual path with the HBA, the channel, the target, and the LUN number that can actually be specified. Another thing for claim rules is that between 0 and 100 are basically reserved by VMware, so one should use anything more than 101. As it happens, 101 is already being used for a standard purpose with Dell Universal Exports. One would tend to use a higher number. So let's add a claim rule. And before we add the claim rule, since we're going to do it by a path, let's see whether we can find some paths. To find paths, we need to find our SCSI devices. Now we're going to look at a certain category of commands that we have not looked at so far. We've looked at the ESXi command set, and that is the preferred way of doing it. But let's look at something which is still available and has been in use for a very long time, which is the ESXCFG -commands. So here we go, ESXCFG, and then I double tab. And what I see here is a whole bunch of commands including a very new command actually for NAS, which we did not look at very closely for NFS, but it's worth looking at. Now, what we are looking at here are the various commands that start with basically ESX CFG, and the one that we are interested in is ESX SCSI devs. So ESX CFG SCSI devs, and the -m option will give us the various data stores and the various devices that we have here. Once we have this, we can then actually look at the paths for the various devices, and that is done with the ESXCFG-mpath command. So I'm going to pick up the canonical name from here by highlighting this much here, and then the dash cap L, along with doing a specific grep for this, will basically show us the various paths that are available at this point in time for that device. And you can see there are quite a few. This 1, 2, 3, 4, 5, 6, 7, and 8 active paths. Now we may, for some reason, at least for our exercise, we may decide that we are going to pick up this path. So it's VMHBA33, channel 7, target 1, LUN 0. That is what we are going to actually mask on. So we're going to define a claim rule. We will use a number higher than 101, and we will say that we are going to define this based on basically the location, which means the actual path that is being used, and the path we'll utilize will be VMHBA33, and we will assign the plugin mask path to that, and then we'll reload the rules, the claim rules, and then you will see that path basically is not available after that. So the first step to do is to actually create that claim rule, and that is done like this: ESX CLI storage core claim rule, add the rule ID, let's use 1001, the type is location, and the address is VMHBA33, the channel was 7, the target was 1, and the LUN was 0, and the plugin we want to associate has this special name of mask path, which does exactly what it says. It masks that path. We hit the enter key, and that claim rule has actually been added, except it looks like there has been a syntax error here. I know what the syntax error is, but before we go there, it's good to actually do the help, because there are some really impressive help options here, and some really great examples of how one can actually do that. For example, you can add a rule 914 to claim all paths of the vendor string of VMware. So you say dash type vendor dash vendor VMware, and then you have a model. So that's the model name, virtual, and then you specify the NMP plugin. So this means that all VMware devices where the model number is has the string virtual in it is actually picked up by the NMP plugin. Some other interesting ones would be around fiber channel, which are based on worldwide node names and port names. So you can see the target, okay, is of this type, fiber channel, and then the worldwide names are specified there. You can also claim paths to specific LUNs at a given IQN. So you specify your T as a target, and then the actual transport type is ESXi, and then you can specify it on an IQN, and then you can do a specific LUN. We are doing it in our example to a specific path on ESXi. So when I retrieve that, I realized that I missed the dash L that was necessary there, and this should work, and it actually does. Let's look at ESX CLI storage core claim rule list to see whether our 1001 rule is in there, and you can see that that is actually in there, and it is for adapter VM HBA33 channel 7 target 1 LUN 0. Anytime I see that path, it will be masked. Now this is not operational at this point in time because I've just added the claim rule into the system. A couple of further steps actually have to be taken to ensure that this is done. So I have to claim rule load. Claim rule has been loaded, and now I list the claim rule again, and you will see that another line has been added. So it's not just now in the file as it was before, it is now in the runtime. Okay, and basically there is a process that would that is done on a regular basis, and it would re-look at the paths and do claims, and that's how that would actually work. As you can see, by re-entering the ESXconfig empath L command for that device, we see that VMHBA33C7 channel 7 target 1 L0, for which we keyed in that rule, is still active, because there is one more step that basically has to be done, and this is a command that is a little bit long. It's ESX CLI storage core claiming reclaim. What that basically does is that, look at the new set of rules, or our new claim rules, and then reclaim a device based on those claim rules. So I will do a right click to put that device ID in there and hit the enter key. And what it says is that it's unable to claim that path, okay, because some paths may be left in an unclaimed state. So we're going to create a claim rule, ESX CLI storage core claim rule add dash rule 2000. That's the rule ID. The type is location based on VM HBA 33. The channel capital C is 5, target is 1, and the LUN is 0, and the plugin is the special mask path, which would then mask that path. I will then do a ESX CLI storage core claim rule list, and we see 2001 there, along with some of the other ones that we have added. So we are looking at 2001 right now. It's in file. We need to load this, so we will say ESX storage core load. We will then run this, and then we will do the claiming. So what we need to do is ESX CLI storage core claiming reclaim, and we need to reclaim that same device that we had before. I think I still have that. No, I don't have that up here, so I need to scroll up and find my device, which was right here. And hit the right click there. So ESX CLI storage core claiming reclaim. So what we're doing is we're basically, for that device, going through the claim rules again to see what has changed, and then act accordingly. So we hit the enter key, and it says the channel 7 was unable to be unclaimed, and the reason is that if this is already in use, and then because there's a data store on it, ESXi, when it goes to the last path, if that's the only path available, then it does not unclaim it. So it would unclaim anything else, but if that's the last path, then it won't do that. So it doesn't unclaim and then a reclaim. So what we need to do now is to look at one more time at ESX CFG -m path -L, and we are going to pipe it to grep, and we are going to use that same there, and we see what that looks like. So as you can see, we have channel 0, 1, 2, 3, 4, but we don't have the 5, because the rule that we added was for VMHPA 33 on channel 5 target 1 L0 to be masked. So it doesn't even show up as inactive. It doesn't even know that the path actually exists. So let's just take a quick look again at ESXi storage core claim rule list, and we will see that the 2001 is the one that was applied here for channel 5, and then you can also see that the 1002 rule for channel 6 was also applied, because you don't see channel 5 or 6 there, and the channel 7 one that existed did not actually function, because that would leave it as the last connected path to that device from ESXi on which there is an existing access which is required. So we'll look at one more time at ESX config empath.l to verify that. So we're looking to make sure that channel 6 and channel 5 are not present. Channel 7, we get the error because we know it'll be the last path, and ESXi will not take down that last path. So we look one more look at that. ESX this one, grab that, and that is certainly the case. 5 and 6 are just not there because they've been masked off. 7 is still there. So that is how claim rules are actually created. Now again, remember that the claim rule can be created based on vendor type, model type, and we saw some examples when we did the help. Now claim rules can of course be removed as well, and the command for that is we are not going to go through that exercise right now, but I will show you what that is. It's just the reverse of what we did. ESXi storage core claim rule remove. Let's say we remove the rule 2001, and when you do the list again, you will see that it's been removed from the file, but it's still there in the runtime. So we say basically load and run. Usually does the trick. Run, and when you list it again, 2001 has gone. Now of course, since the claim rule has changed and now channel 5 is not masked, one would have to basically run the reclaim again to be able to see channel 5 come back online. So that's how paths are masked, and it's a very important technique for VMware system administrators to understand, because this is used quite a lot, and I gave you examples early on as to the various instances in which one would use LUN masking, both on the ESXi side as well as on the storage array side. So with that, we come to the end of this video, which is about LUN masking. The next video is on a very key tool, a very interesting tool as well, to understand how I/O patterns actually work with different kinds of VMs, and so it's called the ESXi stats tool, and I look forward to seeing you on that video.